2.4 Empirical and molecular formulae. The empirical formula is the formula that represents the simplest whole number ratio of the atoms of each element present in a given compound. For example, the empirical formula of carbon dioxide, CO2, tells us that for every carbon atom, there are 2 oxygen atoms. To find an empirical formula, first, find the masses of each of the elements present in a compound by experiment. 2. Work out the numbers of moles of atoms of each element, where number of moles equals mass of an element divided by mass of 1 mole of an element. And finally, 3. Convert the number of moles of each element into a whole number ratio. Sometimes you'll end up with ratios of moles of atoms of elements that are not easy to convert to whole numbers. If you divide each number by the smallest number, you'll end up with whole numbers, or ratios you can recognize more easily. The molecular formula gives the actual number of atoms of each element in one molecule of the compound. It applies only to substances that exist as molecules, though. The empirical formula is not always the same as the molecular formula. There may be several units of the empirical formula in the molecular formula. For example, ethane molecular formula C2H6 would have an empirical formula of CH3. So, to find the number of units of the empirical formula in the molecular formula, divide the relative molecular mass by the relative mass of the empirical formula. For example, ethene is found to have a relative molecular mass of 28.0, but its empirical formula, CH2, has a relative mass of 14. So, relative molecular mass of ethene divided by relative mass of empirical formula of ethene equals 28 divided by 14, which is equal to 2. So, there must be 2 units of the empirical formula in the molecule of ethene. So, ethene is CH2, brackets closed, 2, or C2H4.